Hey everybody, this is Jonathan Salvador, Mr. Salvador. We're going to do our mole conversions video number 3. And this time we're going to convert from moles to particles or from particles to moles right here. All right. So in order to go from moles to particles, you have to know an important number. And that number is Avogadro's number. And Avogadro's number is right here, which is 6.02 times 10 to the 23rd particles. So we know that 1 mole of anything contains 6.02 times 10 to the 23rd particles, 6.02 times 10 to the 23rd atoms, 6.02 times 10 to the 23rd molecules. Doesn't matter, whatever particle it is, it contains 6.02 times 10 to the 23rd. All right, as long as it's 1 mole. All right, so we're going to use the conversion factors, these two conversion factors right here. 1 mole over Avogadro's number, or Avogadro's number over 1 mole. Those are the two we're going to use depending on what we want to convert from and to. If you understand the steps are always the same. We're going to read the problem, figure out the given, figure out what they want, determine the starting point from the roadmap, determine the pathway, and of course set up your train tracks and actually do the math. So we're going to do the first type, which is moles to particles. So example 3 is right here. It says how many atoms are present in 1.6 moles of aluminum bromide, or AlBr3. All right. So figure out what the given is. The given is whatever number and unit that they give us in the problem, which in this case is 1.6 moles of aluminum bromide. Okay. What do they want? They want to know how many atoms, right, of aluminum bromide are in this 1.6 moles. So they want to know atoms, right? So we need the starting point. So we have to look at the roadmap. And when we go back to the roadmap, they gave us, what did they give us? They gave us moles. So we're going to start, this thing is only one way. So we're going to start right here at moles, and we're going to go to particles, which is atoms, which is right here in the middle. And of course, we have to, when we go from here to here, we're going to multiply by the Avogadro's number, right? So we're going to use this conversion factor here because we want what we want on top, and Avogadro's number is on top, and that's the one we're going to use. So again, we're going to go from moles to particles, and the conversion factor we're going to need is this, where Avogadro's number is on top. And then we're going to set up our train tracks. Again, we're going to put what we know, which is 1.6 moles of AlBr in that first box. And then we put in our conversion factor. So 6.02 times 10 to the 23rd atoms is on top, 1 mole is on the bottom. Of course, we can substitute the compounds that we want, which is AlBr3. And once we do the math, and the math is the same, you multiply the top, you divide by the bottom. And when you do that, you get 9.63 times 10 to the 23rd atoms of AlBr3. So do you see the commonality between all the problems we've done? It's basically start with what you're given, put in your conversion factor, and just multiply the top and divide by the bottom. So all the correct conversion factor is the skill here. All right. Okay, now we're going to go the other way. We're going to go from particles to moles. So here's example 4. It says how many moles, this time we want moles, are in 1.204 times 10 to the 24 molecules of H2O water. So again, figure out what's given. Given is this. It's what's given in the problem. So 1.204 times 10 to the 24 molecules. What do they want? They want moles of water. Okay. We are given particles, so we're going to start. So we're going to go back to the roadmap. We were given particles, so this time we're given particles here, and they want moles. So we're going to go from here to here, and this time we're going to divide by Avogadro's number. All right, again, here to here, we're going to divide by Avogadro's number. So that means Avogadro number has got to be on the bottom. All right, so back to here. So that's the one we're going to use, where Avogadro's number is on the bottom. We're going to set up our train track. So what was given? 1.204 times 10 to the 24 molecules of water. 1 mole goes on top. Avogadro numbers goes on the bottom. Okay, we plug in the compounds this time with H2O because that's the compound we're dealing with. And then we do the math. Multiply the top, divide by the bottom, and you're going to get 2 moles of H2O. So again, same steps. Nothing has changed. The conversion factor is the only thing that changed. So that's how you do particles to moles and moles to particles. Again, recognize that the steps are the same, all right? But the conversion factors is what's different, and the train tracks pretty much look the same, all right? Thank you.